All right, friends, so I got a request to maybe make a video that shows the steps for these projectile problems. So I'm going to give it a shot. I'm going to switch to a screen that I can write on so that you guys can see what I'm doing. And I'll post this soon. Hopefully it'll be helpful. All right, so here we go. All right, friends, so I switched to a screen where I can write on here. I'm going to turn on my big screen and write on here for you guys. Hopefully it'll be helpful. Okay, so this first problem is one of the ones from the projectile practice. And it says, Joshua throws a stone perfectly horizontally from a cliff at a speed of 20 meters per second, which strikes the ground 2.0 seconds later. Find the height of the cliff and find the range traveled by the stone. So I'm going to go through the steps to solve this. So I always start out the same way with identifying my variables. So what do I know from the problem? So I know that the stone is thrown perfectly horizontally from a cliff at a speed of 20 meters per second, and it strikes the ground 20 seconds later. So this is a horizontal projectile problem where we know the time. So find the height of the cliff. Height tells me I'm looking at the vertical. So I'm going to start with my vertical variables. So my initial vertical velocity is 0. I know that because it's a horizontal projectile. My vertical acceleration is negative 9.8 meters per second squared. My time is 2 seconds. And that should be about all we need to find the vertical distance. Okay, so I'm going to write down my kinematic equation. That's where I'm going to start. So my vertical height is the initial vertical velocity times the time plus 1/2 times the vertical acceleration times the time squared. Okay, since I know that my initial vertical velocity is 0, this whole term goes away. Okay, so this is 1/2 times the acceleration in the y direction times the time squared. So this gives me 1/2 times negative 9.8 meters per second squared times 2 seconds squared, which if I just plug this into a calculator, I'll get negative 19.6 meters. Now, specifically, it asks you what the height of the cliff is. dy is actually the distance that it fell, but the magnitude is the same. Okay, the next part says find the range, which is the x distance traveled by the stone. So now I'm going to write down my x direction variables. So I know my initial horizontal velocity is 20 meters per second. I know my horizontal acceleration is 0. That's true for all projectiles. I know that my time is 2 seconds. And I think that that's about it. So I'm going to write my same kinematic equation, but now for my x direction. So dx is dix times the time plus 1/2 the acceleration in the horizontal direction times the time squared. So dx, because this term, because acceleration is 0, this whole term becomes 0. So that leaves me with the distance is just the velocity times the time. So this is 20 meters per second times 2 seconds, which is 40 meters. Okay. The second problem is another horizontal projectile problem, but this one we don't know the time. A blue marker rolls perfectly horizontally off of a desk at a speed of 0.78 meters per second and strikes the floor 0.25 meters away from the base of the desk. So I've put all of those variables into this picture, and I'm trying to find dy. So I'm going to actually write down everything I know in the horizontal and the vertical direction. So I'm going to start with horizontal. My initial horizontal velocity is 0.78 meters per second. My initial vertical velocity is 0 because this is a horizontal projectile. My distance in the horizontal direction is 0.25 meters. My distance in the vertical direction, I don't know. That's actually what I'm trying to find. My acceleration in the horizontal direction is 0. That's always true for every projectile. My acceleration in the vertical direction is negative 9.8. And I do also know that my final velocity in the x direction is 0.78 meters per second. But I don't know my final velocity in the y direction, and I don't know the time. Okay, so it looks to me like I know more things in the horizontal direction, so I'm going to start there. So I'm going to write my kinematic equation in the horizontal direction. So this is the initial velocity times the time plus 1/2 times the acceleration times the time squared. So from here, again, I know that this term is 0 because the acceleration in the horizontal direction is 0. So this is just the horizontal velocity times the time. So now notice that I know this value and I know this value. So it should be pretty easy to find the time. So I could either rearrange this, dx equals vx times the time. So the time is dx divided by vx. I just divide both sides by vx. So this gives me 0.25 meters divided by 0.78 meters per second, which gives me a time of 0.32 seconds. Okay. So now, once I have this, I can plug that back in to my vertical direction. So dy is diy times the time plus 1/2 ay times the time squared. So this is, this term goes to 0 because the initial velocity is 0. So this is just going to be 1/2 times negative 9.8 times, sorry, .32 seconds squared. If I plug those numbers into my calculator, I get dy is negative 0.5 meters. So that is the height of the desk. Okay. Now, number 3 is pretty much the same problem, just with different numbers. So I'm going to skip that one. And instead, I'm going to do number 4. I don't know why that says 1. It's number 4. A golfer hits a golf ball at a speed of 35 meters per second at an angle of 25 degrees relative to the ground. Eventually, the golf ball lands directly in the hole. Okay, so this is an angled projectile, and we're looking to find the height, the maximum height that it gets to, the range, and how long it's in the air. This is a typical angled projectile problem. So the first thing it asks you is how much time it was in the air for. So let's start out with what we know. We know that the initial velocity is 35 meters per second, and we know that the angle is 25 degrees. So I'm going to find my horizontal and vertical components here. So if the hypotenuse is 35 and the angle is theta, my horizontal component is down here and my vertical component is over here. So diy is going to be the hypotenuse times the sine of the angle, and my horizontal component is going to be the hypotenuse times the cosine of the angle. And then from there, what am I trying to figure out? What else do I know? Well, the height, when it goes, we're trying to figure out how much time was it in the air. So we're trying to find the total time that it takes to get from here to here. So it goes up and it comes back down. So the distance that it has moved vertically from here to here is 0. So dy is 0. Basically just because this is all on the same line. There's no difference in the vertical location between here and here. So dy is 0. So from that, if I write my kinematics equation, and now, since dy is 0, I can set this equal to 0. Didn't leave myself quite enough space here, so we're going to be a little squished. But that gives me VIY times T equals 1/2 AY times T squared. I'm going to cancel out this T and one of these T's. I'm going to multiply both sides by 2 to get rid of that 1/2. And I'm going to divide both sides by AY. And that leaves me with the time is equal to negative VIY times the time over AY. So this is negative 35 sine 25 times sorry, I don't know why I had that T there. But I did leave out my 2. That's what you get for doing multiple steps at once, right? So this is going to be times 2 divided by negative 9.8. And so now if I plug those numbers into my calculator, I get 3 seconds, or 3.02 seconds. All right, how far away from the golfer is the hole? So now I'm trying to find the range. So that is dx. So I'm going to write my kinematic equation. dx is vix times the time plus 1/2 ax times the time squared. Remember, this term always goes away because the acceleration in the horizontal direction is 0. So this is the horizontal component of the initial velocity times the time. Well, we just found the time up here. So if we plug those numbers in, that is 35 times cosine 25 times 3 seconds. So that gives me 95.76 meters for my range. And then if I'm trying to find the maximum height, that's again vertical. So since we can't see it, I'm going to write down my values again. VIY is VI sine theta, which is 35 times sine 25 in our case. AY is negative 9.8 meters per second squared. And we're trying to find EY. There are a couple ways that we can do this. We do know the time, so we could use our typical kinematics equation, but let's say we didn't know the time. Could we still find our distance? We could. Because we know at the very highest height, the vertical velocity is 0. So this is only at the maximum height. So from that, I know this is my last kinematic equation. So I'm using a different one than I normally do. So the final velocity in the y direction squared equals the initial velocity in the y direction squared plus 2 times ay times dy. So dy is what I'm trying to find, so I'm going to rearrange this. Dy is v fy squared. I'm going to bring this term over to the other side, so minus viy squared minus viy squared. And then I'm going to get rid of that 2ay that's in front of the dy by dividing both sides. So that leaves me with my vertical height is 0 squared minus 35 times sine 25. And you could solve this first if you wanted to and get it to be just a number. That would be fine too. Divided by 2 times negative 9.8. So if I plug those numbers into my calculator, I get dy is 11.16 meters. All right, so that's one example of each type of problem. Hopefully that's a little bit helpful to see the steps written out. Sorry, the writing's a little bit messy, but hopefully this is somewhat useful. All right, my friends, so hopefully that helped you out a little bit. If not, give me a shout and I'll try to explain it a little bit better.